Hello everyone. Today we'll learn how to calculate ndvi from LANDSAT images and how to classify these ndvi values, calculated ndvi values into different classes to identify different levels of vegetation cover of a particular area. For that, first we have to import a shapefile for area for which we are going to calculate the ndvi and classify it into different classes. So I'm taking here the shapefile of Bengaluru Municipal Corporation area, and once I click on this import option, it will import the shapefile into this Earth Engine platform. So it is imported. Now we have to change this name. So I am giving a name of BMC, that is Bengaluru Municipal Corporation. And after importing this shapefile, now our task is to import the image that we want to use for calculating ndvi. So we have to put a name of the variables, and I am using the name L8, uh, which will store the image data that I will import into this Earth Engine platform for calculating ndvi. So the function is ee.ImageCollection, and within this bracket we have to put the code for that particular image. So it is LANDSAT LC02, sorry, 08 collection 02 tier 1 TOA data. So once we put this data code, then we have to filter this data for a specific area, for specific date, and for other criteria. So first we are using the reduce function of geometry. So the function is filterBounds. So the filter bound will be BMC. Then we have to filter the data for a specific time. So the function is filterDate. For that, we have to put a single inverted comma, then we have to follow this particular format, as we are using 2023 01 to 1st January 2023 to uh, 30th, sorry, 30th January 2023. Then we can reduce this image by sorting according to the percentage of cloud cover. So the function is sort, within bracket we have to put a single inverted comma, and that is cloud cover. And then we can sort this image collection by the least percentage of clouds, and the function is first, as we are taking the least amount of cloud cover image, and then we have to finish this part of code with a bracket and semicolon. So after importing this code, now we have to create some variables, and the variables we have to create for selecting particular bands which are required for calculating ndvi. So the first variable is nir. So the function is l8.select B5, that is band 5, and the second variables that we have to create is band 4, that is red. So once we selected both the bands which are required for calculating ndvi, now we can calculate the ndvi. So the variables name will be ndvi, sorry, and the formula will be nir subtracted subtract rate divided by nir dot add rate. And now we can rename this variable as ndvi, or if we are calculating a different indices we can provide that name. So up to this we can calculate the ndvi. Now the part is for visualizing the ndvi on this map space. So for that also we have to create a different variables, and the variables we can create is ndviParam, that is ndvi parameters, and the information that are required for uh, displaying these images, that is the ndvi, is first one is mean value. Mean value is -1. Secondly, we have to put the maximum value, that is 1, and then we have to put a color palette, and the color palette will start from blue, or as per our requirement or as per our choice we can change this color palette. Now we can display, or we can display this image into our map space. For that we have to put a function called Map.addLayer, and first we have to give the name of the data that we want to uh, display on this map space, and then we have to put the displaying parameters, and we have to put a name which will be used for displaying the name of this data. Till now we can run this code to identify whether there is any error in the code or not, or the data is displaying on the particular area or not. So for that we have to go to this Bengaluru part, so the ndvi value is displaying. So the next task is to classify this ndvi image into different classes as per our requirement, or for identifying the proportion of area under different vegetation cover. So for this part we'll classify this ndvi into 5 classes, and to classify this image we have to create a different image. That's why we have to create a variable, and the variable we can give a name of ndvi2, as we have already used the name ndvi. And I have to bring this image, that is ee.Image, earth engine image. Now if we want to classify this ndvi, then we have to write this code where ndvi, the earlier created data, is greater than 0.0 and ndvi less than 0.2 will be considered as class 2, and the rest of the value, that means the negative value, will be considered as class 1. So after that we can again classify the other part of the data using the same function where ndvi greater than 0.2 and ndvi less than 0.4 is considered as class 3. Another class where ndvi is greater than 0.4 and ndvi is less than 0.6 will be classified as class 4. And the last class, we can divide or we can classify the rest of the value as class 5. Once we have completed this classification values, now we can create a different data for this area only. So the variables will be ndvi2, the same variables, and the function will be ndvi2 dot clip by bmc, the geometry name that we have given after importing the geometry into this GE platform. Now we have to display this classified image into this map space. So the function will be Map.addLayer ndvi2, where minimum value is 1 and maximum value is 5, and the color palette we can write different codes, as I am writing here the actual name, that is blue for the first class, red for the second class, yellow for the third class, green for the fourth class, and or we can change this green for class 5 because it is the highest class with higher ndvi value, or we can give a different color for this fourth class, that may be purple. So once we put all this information, now we have to put a name which will be used for displaying the data or displaying the legend. So the name of the uh, data will be classified ndvi, or you can change the name as per your convenience. And last we have to write true for indicating that this image should be classified. Now we can display this image, or we can run this function. So this is the first ndvi that we have calculated for the whole tiles of the satellite image, and this one is the Bengaluru part of classified ndvi value. So once we have classified this image ndvi value, then we can export this data into our Google Drive or Asset or any other platform using the code that are already used in previous videos for exporting the image into Google Drive. So in this way we can classify any of the indices based on a specific threshold value or based on different threshold value for classifying the image or classifying the indices into different categories. So now if we want to change this uh, index, then only we have to change this band name, then it will automatically calculate that particular indices. Thank you all.